16.2 is the only section we have to cover in Chapter 16, and it's over absolute value equations, which a lot of us have seen absolute value before, but we haven't seen it like in the equation. It would just be like, hey, what's the absolute value of negative 5? Positive 5, right? It's the distance from 0. So now what we have to do is we have to keep that idea in our head as we solve these equations. So I kind of have a weird analogy, but whatever's inside is locked in these bars, okay? So in order to come unlocked, we have to think of the positive and the negative that it could be. So I could say, hey, what's in here that when you take the absolute value, you get 2? There's 2 things. What has an absolute value of 2? The number 2 and the number? Nope. Negative 2, right? So whenever you have this absolute value, you have to think what's inside could be the positive or the negative of the right side, and that's the key to unlocking the bars, all right? So P equals either 2 or P equals negative 2. Since the only thing inside the absolute value bars was just the variable P, there's no solving, right? If we put in 2, what's the absolute value of 2? 2. If we put in negative 2, what's the absolute value of negative 2? 2, right? So we solved both of those. Now it's going to be the same idea, but there's a little bit of solving. What is in these bars that will pop out of an absolute value of 7? 7 or negative 7, right? The inside could be either positive 7 or negative 7. So let's see what variable gives us that. So what you do is you take the inside, 5w plus 3, and set it equal to 7. But you also set it equal to negative 7. Remember, the only reason why we're doing this twice is because the inside could equal that positive or that negative. Alright? And then it's just 2 equations that you'll solve. So subtract the 3 over, and you'll get 5w equals 4. Does that look right? So in this one, w equals 4/5. On the other one, we're going to subtract the 3 over, but since we're subtracting it from a negative 7, it will leave us with a negative 10. So w will equal what? Negative 2. My thing I want to point out is some people think they only have to solve one equation and just say the answer is going to be the positive and negative of that, just kind of like this, right? I'll solve it for 2, so it's 2 and negative 2. But this is a good example of where you have 2 solutions that are not the positive and negative of each other. 4/5 is just what you get when you put it in here and you get 7. So if you put 4/5 in there, that 5 up there, we cancel out with that 5 down there. That would leave you with 4 plus 3 or 7. What's the absolute value of 7? 7. So we know he's good. And then negative 2, if you plug them in there, 5 times negative 2 is negative 10. Negative 10 plus 3 is negative 7. But what's the absolute value of negative 7? Positive 7. So he's good as well. Alright? So the key thing is to make sure you get the absolute value equation isolated and equal to your constant, and then you can just set it equal to the positive and the negative. Alright? So whatever's in here, what must he equal? Either 11 or negative 11. So let's just do that. X minus 2, or excuse me, x divided by 2 minus 1 either equals 11, or x over 2 minus 1 equals negative 11. Because when we do all the math, we know the absolute value of 11 is 11, but we know the absolute value of negative 11 is 11 as well. So we'll go ahead and solve. Our first move will be to add 1 over. So we have x over 2 equals 12. And then guys, what's the opposite of division? Multiplication, yep. So we're going to go ahead and multiply both sides by 2. Over here this will cancel out, and over on the right it'll be 24. We're going to do the exact same thing, but on the right-hand side. Add 1 over, but when you add 1 over, it's going to get us to negative 10, but then you got to time, so you get x equals negative 20. And again, I just check real quick. Throw 24 in there. What's 24 divided by 2? 12. What's 12 minus 1? 11. What's the absolute value of 11? 11. So he works. Throw negative 20 in there. Negative 20 divided by 2 is negative 10. Negative 10 minus 1 is negative 11. But what's the absolute value of negative 11? Positive 11. So he works as well. Okay? So the key thing though, guys, the only reason why we can unlock these bars and equal it to the positive and the negative is because the absolute value is isolated. So we need to get this absolute value by itself first. The only reason we can do the positive and negative is because of the absolute value. Does that 5 have anything to do with the absolute value? No. So we got to move him over to the other side first, okay? So let's move the 5 over because he has nothing to do with the absolute value. And we're left with the absolute value of 2x equals 2. Now, we basically made it look like all the other problems we've done. We've isolated our absolute value, so how do we unlock the bars? We set the inside equal to the positive and the negative of the right. But you have to isolate first. Isolate first. We've got to isolate first. We can't set the absolute value of 2x plus 5 equal to 7 and negative 7 because that 5 has nothing to do with the absolute value, okay? And the only reason why we do this is because it had the absolute value. All right, divide both sides by 2. You get x equals 1. Divide this side by 2. You get x equals negative 1. So this is an instance where they are the positive and negative of each other, but that doesn't always happen. I like to check it, so I'm going to throw 1 up here. 2 times 1 is 2. The absolute value of 2 is 2. 2 plus 5 is 7. Throw negative 1 in there. 2 times negative 1 is negative 2, but what's the absolute value of negative 2? Positive 2. 2 plus 5 is 7. So both of those work, but we got to isolate first. All right. Is that okay? Not too bad. Number 5, they try to kind of give you a trick question. There's no such thing as positive or negative 0, okay? So when you have an absolute value, whatever's inside the absolute value equal to 0, you just set it equal to 0 and solve. So the inside, guys, is just 0. But notice there's no solving, okay? So that is just done, all right? If that was like 5w plus 3 equals 0, then you would set 5w plus 3, whatever the inside is. So set inside equal to 0. Set inside equal to 0. Because it won't always be that easy, you know? You'll have some solving. All right, let's look at this next one, number 6, okay? We can't just set all this equal to positive 23 and negative 23 because that's just the absolute value that has that positive and negative. So we got to get that absolute value isolated first. So what's the first move we're going to make? We move everything to the right. Yep, so we're going to subtract the 25 first. So we have 2 outside of our absolute value of x equals, what is that, negative 2? Does that look okay? And then what are we going to do? Divide both sides by 2. So over here you have the absolute value of x equals negative 1. And then stop right there and I'll tell you why. So we do all this math, we move the 25 over, we divide by 2, and then we get our absolute value isolated, right? But what do we know about absolute value? It's always positive. So tell me, guys, what can I put in here that when you take its absolute value, you get a negative 1? It's a trick question. There's nothing, right? What always comes out of an absolute value? A positive number. So we'll just say no solution here. Absolute value is never negative. Absolute value is never negative. Okay? And don't be too quick to do that. So like here, the second we subtracted the 25 over, we got a negative 2. This could be a negative out in front, and so when you did a negative divided by a negative, it could be a positive. So wait till the very end. Wait till you get that absolute value isolated. If that equals a negative, guys, just stop. So like one on your worksheet, I think it starts with the isolated equaling to a negative. You don't have to do anything. You just say no solution because there's nothing. And think about it. Like go back up to here. What pops out of an absolute value, which is positive, times by 2 and add it to 25 to go back down to 23. There's no way that can happen, right? All of this would be a number bigger than 25 or 23, so it just can't happen. All right, are you guys okay on that front page? Not too bad? Look at number 7. It's exactly what I'm talking about. What do you notice? We have the absolute value. It's isolated, but what is it equal to? A negative. Never possible. So we have a bunch of space to just write no solution. Right? Our absolute value is already isolated. and is equal to negative, that can't happen, okay? So then you just say no solution. Not a whole lot of work. All right, the last two are kind of weird because you have an absolute value equals an absolute value. And I'll kind of show you real quick. This is kind of how the book shows it. Don't you guys agree? You don't have to write this. Don't you guys agree that this is true? Right? The absolute value of 2 is equal to absolute value. Don't you agree that this is true? Right? But isn't this true?
Yeah.
Yeah, because what's the absolute value of negative 2?
Positive.
Positive 2. So both of those positive, and then don't you agree that this is true?
Yeah.
So we kind of had two scenarios, like you're like 2. I see 4 right there. No, we have two scenarios. We have this scenario where the insides are just equal to each other, right? 2 equals 2 and negative 2 equals negative 2. And then we have this scenario where the insides are equal to the opposites. And that's what we're going to do, guys. Whenever you have two absolute value equations, you're just going to take the left and equal it to the positive. So 3x plus 2 equals 5x minus 8. So kind of like what we've been doing, right? You take the inside of the left and set it equal to the positive of the right. But we're also going to do 3x plus 2 equals the negative version of the right. So 3x plus 2 equals the negative version of the right. And that's kind of what we've been doing, but the right's always been a number, right? It equals 7 and negative 7. So on this one, guys, we're just gathering like terms. So I'm going to move my 3x over. I'm going to add my 8 over. So I get 10 equals 2x, or x equals 5. Does that look like what you guys got? And you can go either way. You can move your 5x over to get negative 2x, and move your 2 over to get negative 10. Either way, you should get a positive 5. Is that okay on that one? On this one, what we have to do is we have to make sure we distribute the negative to both parts of the right side. So we're going to make sure we have 3x plus 2 equals negative 5x and positive 8. All right? I like to keep my x's positive, so I'm going to move my 5x over this time to the side, and I'm going to move my 2 over there. So I'm left with 8x equals 6, or x equals 6 over 8, but that reduces to 3 over 4. When you go to check it, if you plug 5 in, the left will equal the right. So 3 times 5 is 15, 15 plus 2 is 17, and if you plug it onto the other side, 5 times 5 is 25, 25 minus 8 is 17. So 17 equals 17. 3/4 is a little bit trickier to check. But whenever you do it, the left will equal the negatives of the right, but that's okay, because what are they both in? Absolute value, so the positive will pop out. All right? Last one, we're just going to do the exact same thing here on number 9, guys. We're going to take x minus 3 and set it equal to the positive of the right, 5 minus x. And we're going to take x minus 3 and set it equal to the negative of the right, so the negative goes in front of that 5 minus x. Alright, so I'm going to move the x over and move my 3 over. So I get 2x equals 8, or x equals 4. Does that look right? And then over here, I'm going to make sure I distribute first. So you have x minus 3 equals negative 5x plus x. But when you move your x over and move your 3 over, you get something weird. You get 0 equals negative 2. So x equals 4 is one of your solutions, because you'll move that 3 over and move that x over. On the right, though, what you have to do is you have to make sure you distribute that negative, but the second you distribute that negative, you change the sign of your x, so when you move it over, they cancel each other out. And so I just come over here, is this a true statement? Does 0 equal negative 2? No. So that's just not part of your solution, and x equals 4 is your only answer there.